So this is number 6. This is the problem which you can rewrite that as x cubed minus 108 over x squared. Again, the first question, what is the x-intercept? That's you let y equals to 0. When you have a fraction, for the fraction to be 0, that means the top has to be 0. X cubed has to be 108. X has to be the cube root of 108. So the x-intercept is the cube root of 108 and the y value is 0. Now find the min and the max. It means I need the derivative. To find the derivative, I got to be crazy to use this one. I should use that one. Why? Because if you rewrite this, isn't that x minus 108, x to what power? Negative 2. So what is the derivative? I don't have to use a calculator for that. That's straightforward. Derivative of x is what? 1 minus times a minus plus 2 times 108, which is what? 216. X to what power? Negative 3. Or x cubed plus 216 over x cubed. Critical values. That's where the derivative is equal to 0 and where the derivative is undefined. When you have a fraction, for the fraction to be 0, that means what? The top has to be 0. When is x cubed plus 216 will be 0? That's when x cubed equals what? Negative 216. Can we find what x is? What is the cube root of negative 216? It can be. What is the cube root? 216 to the power of, or negative 216, sorry, parentheses, negative 216 in parentheses to the power of 1/3. Or if you have a cube root button, go ahead and do it. You got a number for it?
Negative 6.
You got negative 6? You sure?
Yeah, I got that too.
Negative 6? I didn't get negative 6. Yep, it is negative 6. I don't know what I got then. Oh, I didn't put parentheses around it. Yep. X equals negative 6. And when is the derivative undefined? Derivative is undefined when the bottom is 0. That means x equals what? 0. X equals 0, it can't be, because my function says x cannot be 0. That's not a min. That's actually a vertical asymptote. That's one of the questions. Where's my vertical asymptote? And that's what value makes the problem undefined. X equals to 0. That's one of the questions. So we answered 2 questions so far.
How's the best way to tell whether the number you got for your is either a vertical asymptote or just one of your bits?
Whether this is a vertical asymptote or not?
Yeah.
From the function itself.
Okay.
Is the 0 make the function undefined?
Yeah.
That's a vertical asymptote.
Okay.
Not the derivative of the function itself. Once we know that's the case, it's going to be in the first derivative and it's going to be in the second derivative. So when I'm graphing, if you remember when I made my box here, last class, when I try to make my box here, these wheels look good on TV, on camera, the pink ones. I saw one of my slide today has the pink this, stands out, boom, can't miss it. I need to invent a new ruler that has like 2 pieces, so I don't have to keep moving it, attached with something. So this is for the first derivative, this is for the second derivative. We said we have a vertical asymptote at 0. So let me draw a line going through both them. 0 and the y value is either plus or minus infinity. We have no idea. Now we found a critical value to be what? Negative 6? Wasn't that negative 6 one of them? And when x is minus 6, what's the y value? Let's plug it in. What's negative 6 minus 108 over 36? 108 divided by 36? 3. What's negative 6 minus a 3? Is that a negative 9? Do we have any other values beside the negative 6? No. Let's look at the first derivative, the derivative right here. If I use a value less than negative 6, like a negative 10, negative 10 when you cube it, what's that, negative 1,000? Plus 216, is that negative or positive? Negative over negative, which is what? Negative or positive? That's a positive. That's increasing. Between negative 6 and 0, how about a negative 1? That's a good number to use. What's negative 1 cubed? Negative 1 plus 216, positive or negative? That's positive divided by negative, which is what? Negative. That's decreasing. This is a max value. Bigger than 0, let's use a 1 or a 10. That's 1 cubed, that's 1 plus 216, that's a positive. This is positive, that's a positive. Increasing. This is not a min, because that's a vertical asymptote. There's a hole in it. So now we have an answer. One of the question is, can you tell me where the relative max and relative min? We have a max. You can see the relative max. Here we go. Relative max at what? Negative 6 comma negative 9. Relative min does not exist. D and E. We don't have a min point. So relative min, D and E. It says answer D and E if it doesn't exist. And the other one we said, what was it? Negative 6, negative 9. Don't use parentheses. They already have the parentheses for you. Already put in. Now the only question left, inflection point, and that means the second derivative. So let me put this aside. I'm going to need it in a few minutes. I need the second derivative. The second derivative. What's the derivative of 1? 0. This will be a minus 216 times 3. 648 x to what power? Negative 4, which is negative 648. When is the second derivative going to be 0? And when is it undefined? For the second derivative to be 0, that means the top has to be 0. This will never happen. For the second derivative to be undefined, that means the bottom has to be 0, which is what? X equals to 0. We knew that because that's your vertical asymptote. So there is no additional cuts for the second derivative. 0 is the only cut. I can try a negative value and a positive value, and I will not have an inflection point because there's a hole right there. So when x is negative, what's the second derivative? This is positive always, because that's the fourth power. This is always negative. What's negative over positive? Negative, concave down. Negative, concave down. No inflection points. So where's the inflection points? They asked for that. Does not exist. So that's the answer for the other one. And we said the slant asymptote, that was the last question. When you look at this, when you divide them, it's really this plus that's the remainder. So the slant asymptote here, it's always y equals to the quotient. The quotient is x. And that's plus the remainder, which is negative 108 over x squared. So that's your slant asymptote. So just knowing this information, I can graph it. All the stuff in front of me here, I said, let me graph it. Let me just take a piece of paper. This is the x and the y axes. Here's what I know. Let's write what we know. We have a slant asymptote at y equals to x. Y equals to x is this line. That's your slant asymptote. Y equals x. We have a vertical asymptote as 0. X equals 0. That's a vertical asymptote. VA, x equals to 0. Let's look at negative 6. Here's my table here. Negative 6 and negative 9. Negative 6 and negative 9, I'm assuming somewhere here. I wish I have a graph paper. Oh, you know what? I have a graph paper. Wait, because I want to see where that point is. I have a graph paper. My wish came true. Right there. Let's try to graph it to scale and see what will happen. Slant asymptote, y equals to x, that's diagonal, going through all these lines. Vertical asymptote is right here. Because I was guessing on that point. I don't like guessing. X equals 0 is my VA, vertical asymptote. Now, we have, what was that point? I'm just going to go to this chart. We have a maximum value at -6 and -9. Minus 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a maximum point, like this. Before that, the function was increasing. Well, it can't go above this line, so increasing is coming from here to this point. Once it hits this point, start to do what? Decrease. Notice concave increasing, concave downward. Then it's going to decrease, concave downward. And as you're approaching that line, we say your function is either going to go plus or minus infinity. Well, if you're coming down this way, it's going to go where? Toward negative infinity. It's not going to go back up there. If it did, we'll have a max point or min point. After that, the function, according to this one, increases concave which way? Upward. Increases from here. Now, if I have my x-intercept, which we did calculate, that's where? Roughly 4.7? Somewhere here. So my function is actually always increasing, concave upward. That's what it's going to look like. Do we have a picture that looks like that? B, I think. Nice, beautiful picture with the graph paper. It's increasing, concave downward, and it passes through roughly 4.5. 4.6, I think. The cube root of 108. It passes through that point. When you graph it, you got to make sure you don't have all these sharp edges there. Looks like fish, I don't know, skin there. But nice smooth curve going up there. But that's the significance of the slant asymptote. It lets us know where we're going to start from and where we're going to level at. Oh, I forgot to answer the slant asymptote. It told me actually the maximum value, unless they want me to write infinity. I put D and E and they said wrong. I wonder if they want me to write infinity. Because notice, where's the function going to? Isn't that going to infinity? So I wrote D and E, but maybe they want to write infinity. Let me try infinity for that one. And the slant asymptote, I forgot to write that. Y equals X, I think I said, for that problem. Did I give up? I want to see what they want the answer. How do we know what they want the answer? Is there a way to see how they want the answer written?
If there's a try another version, you can get that one wrong on purpose.
Practice another version. I don't want to do it. I just want to know how they want the answer written.
Well, yeah, if you just,
Practice, if I had that.
I do the practice one and then just throw in whatever in there, but have the mark be wrong and then it'll show me the answer.
So I'm going to write here relative min 5 without even making a point. 7 here, which is not a point, and 12, not a point. And the slant, hi mom, So submit. Or grade this,
Yeah.
and let's see how they want the answer.
It would show the answer too.
It never did show me the answer. Jason,
No, there's, on the bottom, there's a button that says show answer. It's grayed out until you get it wrong.
Yeah.
Yep.
I gotta do it again?
No.
No.
Show answers, yes, yep, I got you, yep. Got you, yep. See, here we go, I'm learning. D and E, -6, -9, yep. Oh, you know what? I put them in the wrong places, the -6 and 9. That's the max point, right? I put it in the min. And I put the other one does not exist in the wrong place. My finger's really not red. I don't know why it looks red there. That's the max point. When I type that, I put in the min. In the max, I put does not backward. But, yep. Y equals X was the slant asymptote, by the way. They want it that way. And for the answer, actually, for the intercept, I put the cube root of 108, and they took it. So you can leave it like that. And D and E was fine, yes. It just I put them in the wrong place.
So what do they want for the maximum on that?
There is no maximum. Does not exist.
Okay.
When I typed my answer, my maximum for this is -6 and 9. You know, the minimum, that's my maximum. I'm sorry, there's no minimum. That's my relative max. In this neighborhood, that's the maximum value. You know, so you gotta write that one. There is no min. That's the maximum value. And that's why I wrote here, we have a maximum value. But I put it in the minimum instead of the maximum box. Where was it? So yeah, so we have a maximum at -6, -9. But when I typed it, I put that in the minimum by mistake. So I was wondering why I marked it wrong. Not even noticed that. But now I learned something new. Now, how do you get out of it, Jay?
Oh, you just close the window
Close the window? Okay.
to set up.
Oh, yep, you're right. There we go. I like this. I'm learning. Number 7, very similar. Let me look at number 8. God. I can probably whip number 7 quickly by cheating using the calculator for the derivative, so I don't have to find the derivative. There's no quick way for these, by the way, unless I use my calculator to give me the derivative. F of x x cubed again the intercept. No, it doesn't say which intercept. We'll do the x-intercept first. X-intercept, you let y be 0. If you let y equals 0, you have 0 equals x cubed over x squared minus 16. The only way this would be 0 if the top is 0. X equals 0. So my x-intercept 0 and 0. Since it didn't say which intercept, let me find the y-intercept. You're going to find out in this case the same point. You let x equals to 0. If you let x equals to 0, y equals what? 0 over 0 minus 16, which is what? 0. What do you know? It's the same point. So that's why they didn't call it x-intercept or y-intercept. They said the intercept. It happens to be the same for both the x and the y. That's 0 comma 0. I'll come back to the relative min, relative max. Vertical asymptotes quickly. What makes the bottom 0? Try again. I said asymptotes with an S. Yep. X squared minus 16 is 0. X squared equals 16. X equals plus or minus 4. I got 2 of them. X equals plus 4, x equals negative 4. Do they ask for them? Find the equation of the asymptotes. The smaller x value, they want them separate. X equals -4. The larger x value, x equals 4. Notice the top is higher than the bottom. You will have a slant asymptote. So before I forget about this, let me go to my table. Table is my buddy here. Allows me to do everything I want to do just by looking at it. This is for the first derivative. This is for the second derivative. We have vertical asymptotes at -4 and 4. And I always make them red because I don't want to mess them. I want to make sure I see them. I don't want to overlook, so I make them really bright colors. And it's going through both of them. They will be in both. -4 and D and E does not exist. That means plus or minus infinity. It's going through both. They will be in both cases. Since the top is higher than the bottom, we find the slant asymptote. And to find the slant asymptote, I got to divide these by doing long division. We take x cubed and we try to divide that by x squared minus the 16. What is x cubed divided by x squared? X, what's x times x squared? X cubed. What's x times a -16? -16x. Just like numbers, you want to subtract this from that. What is x cubed minus x cubed? Gone. What is nothing minus a minus 16x? Positive 16x. So we can write f of x now as the quotient, which is x, plus a remainder of what? 16x over what? X squared minus 16. This over that.
Be minus 16x over
Minus a minus. Remember, you subtract, you change,
yeah.
just like with numbers, you change the sign, add them, or you subtract them. You got to subtract this from that. So minus a minus 16 will make it a plus 16. So my slant asymptote now, y equals x. That's my slant. Is wherever the quotient is. Quick reminder before I forget, graph paper is nice. We have it here. Here we go. Slant asymptote y equals to x. That's a 45-degree angle. Y equals x. That's my slant asymptote. We have x-intercept where? -4 and 4? 1, 2, 3, 4. I mean vertical asymptote. I'm sorry, I didn't do the x-intercept yet. X equals 4. That's your VA. X equals -4. 1, 2, 3, 4. That's my vertical asymptotes. When I'm ready to graph, I'll look at these. That's what I know so far. So the next question they're asking me, slant asymptote y equals to x. Let me just type it in. Y, where's the equal sign? Equals x. Okay. The next question they're asking is, can you tell me the min, the max, and the inflection point? Which means I need the derivative. So here we go. The min and the max. What is the derivative? Again, I'm going to cheat to speed up the process here. I'm going to use my calculator to find the derivative, but if you were to do this by hand, what method would you use? Quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom divided by what? The bottom squared. So if you did that, your answer should be, let me just write that, x to the third divided by x squared minus the 16, and I want the derivative of that. And here's my calculus, is the derivative of x cubed over x squared minus 16 is, they were nice to me, they factor it out. It says x squared times x squared minus 48 over x squared minus 16. Can you see that on the screen? Squared. Now, let me find out where the derivative is equal to 0, because these are the critical values. That's where your min-max points. Or where the derivative is undefined. For the derivative to be 0, that means the top of that fraction has to be 0. Oh, that's x squared, isn't it? Yep, that's x squared here. So for this to be 0, that means x squared has to be 0, or x squared minus 48 has to be 0, which means x is 0 if you solve this one. If you solve that, x squared equals what? 48. X equals plus or minus the square root of 48. 48. Can we break it down 4 times what?
It's like 6.92 or something like that.
Well, what about fractions? Is that 16 times 3? Is that 48?
Yeah.
So, because I'm sure they want the exact answers, Nico.
You can do 4 radical 3.
So it's going to be plus or minus 4 the square root of 3. Approximately, if you try and figure out what that number is, Nico said, that's square root of 48, right? Excuse me. It's roughly 6.9, almost a 7. Almost a 7. It's not 6.9, some change. So now let me go back to my table here. Where's the derivative undefined? I never finished it. That's when the bottom is 0. X equals what? Plus or minus 4, isn't it? So we have a lot of critical values here.
Now, those are going to be your vertical asymptotes or no?
This is your vertical asymptote, yes. I thought I made the table. Did I start with the table? Yeah. Oh, I have it somewhere here. Yep. So the 0 is another piece that's going to cut it here. We have 1 here. Negative 4, the square root of 3. And we have 1 here, which is 4 the square root of 3. I don't like this, too many points. Who picked that problem? Let's find the x value that goes with it. I'll start with the 0. The 0 is an easy one. When x is 0, what's y? 0. When x is this number, negative 4, the square root of 3, clear that. Let's see what the value there, so I know. Cube divided by parentheses squared minus the 16. No, escape. I got an error. I forgot to close the parentheses. Did I forget something here? Wait. With this calculator, I'm putting every digit under the sun here. So that's cube. There we go. Oh. Squared minus the 16. I got approximately 10.39, 10.4. Is that what you got? And when it's a plus, oh, wait a minute. That was a minus, right? I forgot that. That's the 10.4 is here. I used the plus. Let's see what the minus is. Minus to the power 3 divided by that number to the power of 2 minus the 16. Negative, this is a negative 10.4 and that's a plus 10.4 approximately. Remember, that's a negative. Hopefully I remember that. So let me use a value, test point in each one of these segments. We said this is almost a 7, 6.9. So let me use a negative 10. Make my life easy. Between negative 7 and negative 4, how about a negative 5? Between negative 4 and 0, how about a negative 1? Between 0 and 4, how about a 1? Between 4 and 6.9, how about a 5? And more than the 6.9, how about a 10? Here's the good news, by the way, for us. When I say good news, notice x squared is always what? Positive. The bottom is always what? Positive. So I know in terms of the derivative, the first piece is always positive. I know the bottom is positive. So the only thing is this piece. If this piece is positive, the whole thing is positive. If this piece is negative, the whole thing is negative. Can you see that? So it's negative 10. What's negative 10 when you square it? 100. 100 minus 48, positive or negative? Positive. That is increasing. When it's negative 5, 25. 25 minus 48, negative. Decreasing. That's a max. A whole here. A minus 1. What's minus 1 squared? 1. 1 minus 48? Negative. Decreasing. 1. When you put a 1, that's 1. Minus 48? Negative. That's still decreasing. That's not a min or a max. A whole here. Let's try the 5. 25 minus 48, negative. Decreasing. Let's try the 10. 100 minus 48, positive. That's increasing. What do we know? We got a min here. I got a max and I got a min. Relative min. So only one value. What is the min? 4 the square root of 3. What was that number, the y value?
10.4.
Yeah, I'm sure they don't want a 10.4. They probably want the exact value. So I really got to go back and plug it into the problem to get the exact value for it. No, probably like cube. I'm talking about cube root or something. You know what I can do? If I can find it on my calculator, I can ask the calculator for an exact answer. Was it 6? Is it the square root of 48? No, that's a 6.9. Not the 10.4.
So it's the 6.9282.
So I'll just skip it. But you gotta put the exact value. They won't like the 10.4. I'm sure they're gonna have the square root, the cube root, whatever is written there. Whatever that value there. I'll just graph it. And the next one, I'm done with the first derivative. Now what about the second derivative? Let's take the derivative of that. Here we go. Clear? The derivative of, oh, you gotta be kidding, I deleted it. Okay, F3, the derivative of this one, which is x to the fourth minus 48x squared divided by x squared minus 16 squared close that with respect comma x. I have an extra parentheses here. The derivative, oh, here we go. The derivative of x, can you see it? X to the fourth minus 48x squared over x squared minus 16 squared is this one. Can't see when I put that grid on it, but there's the answer. So the answer for that, using my cheat method again, 32x times x squared plus 48 over x squared minus 16 cubed. So I know that minus 4 and plus 4 is still part of the second derivative down here. I'm good here. When is the second derivative going to be 0? That's when the top of the fraction is 0. This is actually good. There's only one possibility. Or when x squared plus 48 is 0. This will never be 0. This one when x is what? 0. And when is the second derivative undefined? Still at what? Plus or minus 4. So that's actually good news to me because there's no more values except extend this line all the way down. And let's take a test point in each one. I'll do the minus 10. I will do the what? Negative 1, 1, and the 10 for a test point into the second derivative. Can you see the second derivative? I know this piece here is always what? Positive. That's always a positive, so I don't have to worry about that. The bottom, we're not sure. If I use the negative 10, let's think about it. If I use the negative 10 here, what's 32 times the negative 10? Is that a negative number? Negative times positive, which is what? Negative over. When x is negative 10, that's 100. 100 minus 16 positive. Cube, that's a positive. What's negative over positive? Negative, concave, downward. if I use a minus 1, 32 times a minus 1 is what? Negative. The other number is positive over. When it's minus 1 squared, that's 1. 1 minus 16, negative 15. Cube it, that's negative. What's the result here? Is that a positive? Concave upward. It looks like an inflection point. It's not. There's a hole here. Take the 1. Plug it in. That's positive. Positive over negative. That's a negative. Concave downward. There's an inflection point. And if I take the 10, positive, positive over positive, that's a positive. Concave upward. And now I'm ready for my graph now. I got almost negative 7 and 10.4. 1, 2, 3, 4, 5, 6, 7. Negative 7 and negative 10.4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So somewhere here we have a max point. Before that point, the function is increasing concave which way? Downward. Increasing concave downward, hits that point. Then what's going to happen after that? Decrease concave downward. Zero, zero is an inflection point here, this point. That's an inflection, 0, 0. Before this point, to the left of it, from this red line to this point. Can you see him on the screen? It is decreasing concave upward. Well, the only way that will happen if it goes like this. Then what happens after that point? Decreasing concave which way? Downward. Looks like this, coming down. And what about after that? We have a midpoint where? At 4.3, I mean at 7 almost. 1, 2, 3, 4, 5, 6, 7. And 10.4. 1, 2, 3, 4, 5, 6, 7, 8, 10. 10.4 here. The function was decreasing concave upward. Decrease, that means coming from up there. Concave upward. Then it goes like this. And that should be my graph. If I look for the graphs, one of them is going to look like that.
What are the rules for being able to cross the slant asymptote?
You can't cross them. You approach both. And asymptote, you can't cross them. You approach them.
Okay.
Especially the vertical one. Definitely you cannot cross the vertical
You're
one.
not crossing that slant.
Nope. You're approaching the asymptote. Because you know it's going up, you're just not sure how fast, where it's going to land. So this will help you where to start from and where you're going to level at.
There's really a hole there at 0, 0?
At 0, 0? No, not a hole. That's the inflection point, change of concavity.
Yeah, but how are you crossing this? You're crossing the slant asymptote.
No. You can touch that, the slant asymptote. You're touching it here. You can't cross the vertical asymptote. The slant asymptote, you can touch it, but you're approaching that here, and you're approaching, so you never cross it here or there. You can actually, you can have a function, if this is slant asymptote, you can have a function go like this. And at the end, we'll level with it, you know?
Oh, okay.
So in the end, it's going to level with it. So you could cross as many times rather than just gonna go level like this, you know. So, but you can't cross the vertical asymptote. The vertical asymptote, your function does not have a value there. So these will never be crossed.
Learn how to cross answer. Okay, so 12, 13.
I'll do one more, and then I'll move forward. I don't have time for all of them. Actually, I get two more, but I'm gonna. 11 is really straightforward. Let me see. I did 7. Maybe something uglier. Maybe I'll take 8. 8 is uglier than 7. I mean, than 11. So I'll leave 11. I'll do 8. You can see these problems take a long time. We'll be here till midnight. Oh, God. F of x equals 12 x to the 2/3 minus 8x. No vertical asymptotes here. Nothing. It says the intercept. X-intercept, you let y be 0. So you have 0 equals 12x to the 2/3 minus 8x. Or you can say 8x, if you rewrite it, equals what? 12x to the 2/3. Let's divide everything by x to the 2/3, both sides. What do you have? 8. What's x over x to the 2/3? X to the 1/3 equals 12. Divide by 8. X to the 1/3 equals what? You divide 12 by 8. Is that 3 over 2? Divide by 4. That's a 3. Divide by 4. That's a 2, right? How do you make it x? This is x to the 1/3. Don't you cube it? So what is x equal to? What's 3 cubed? Is that 81? What is 2 cubed? 8. So that's your x-intercept. 81 over 8 and 0. Again, they don't want to see decimal values, so you got to do all this algebra. One thing about this class, like it or not, it made your algebra much, much better than when you came into the class. You probably don't like that, but it really did. There's a lot of algebra involved in that. The y-intercept, what do? You let x equals to 0. They're asking you for these questions. If you let x equals to 0, y equals what? 0 minus 0, which is 0. So that's 0 comma 0.
3 cubed, 27.
3 cubed. 3 times 3 is 9. Times 3, 27. Yes, thank you. I knew that. I thought about that too earlier. 27 times 3, 81. I don't know. So 27 over 8, not 81 over 8. 3 cubed is 27. I can do the fancy math, but I can't do 3 cubed. And the y-intercept intercepts 0, 0, right? Notice they didn't say which one the x-intercept, and if I type them the way I typed them, I'll get them wrong. Because the way they want them written, they want the smaller x value first and the larger x value second. So I gotta write the zeros. It doesn't say x and y intercept. It says just write the intercepts. So in the first box, I gotta write the 0, 0, because 0 is smaller x value. And the other one is what? We said that's, what is the fraction? That's a 27 over 8. That's the larger x value. And what was the y value for that? 0 again? Comma, not a period. Comma. So you got to be careful when you enter them. You might be thinking, are these x-intercept? No. One is x, one is y, but they want you to write the smaller x value first. 0 is less than 27 over 8, so they want you to write this answer first, this one second. If you write them backward, they're probably going to mark it wrong. Next, find the min, the max. The min and the max. Do we have any, by the way, vertical asymptotes? No. No vertical asymptotes. That's when you have fractions. Or asymptotes. No. Do you have any horizontal or a slant asymptote? Slant asymptote, when you have a fraction and the top is higher than the bottom. So what is the equation for the asymptote? D and E. We don't have any. Now the next question, the min and the max and the inflection point. We can do the derivative by hand, it's not that difficult. I almost reached in for my calculator to do the derivative, then I shook my head like, you gotta be kidding me, I gotta use a derivative for, a calculator for this? What's f prime of x? What is 12 times 2/3? 24 divided by 3, that's 8. X to what power? 2/3 minus 1, which is what? Negative 1/3 minus the 8. Which if we clean it, that's 8 over the cube root of x minus 8. If you don't like the way this one is written, that's 8 minus 8, the cube root of x, over the cube root of x. LCD, this is over 1. You got to multiply the top and the bottom by the cube root of x. That's why it's up there. When is the derivative equal to 0? When 8 minus 8, the cube root of x, is equal to 0, or 8 equals 8, the cube root of x, which means x is what? 1. When is the derivative undefined? That's when the bottom is 0. Which means x equals what? 0. Okay. Let's make a box. The usual procedure here. First derivative, second derivative. I have two critical values, the 0 and the 1. X is 0. I think I found the value when x is 0. What was it? Y is 0. I already did that. The other one, x is 1. And what's the y value when x is 1? The y value. Isn't that 12 minus 8? Which is 4. Notice I put that sheet away. I don't need it now. All this stuff is going to be right here. Take a test point less than a 0, negative 1. Between 0 and 1, 0.5. More than 1, 5. When x is negative 1, what is the cube root of minus 1? Isn't that negative 1 times the negative 8, that's plus 8. 8 plus 8, that's 16. Over what? Negative 1? Positive over negative, which is what? Negative, that's decreasing. The 0.5, ugh. I know the bottom is positive. What about the top? The top is going to be what? Positive. Why? Because if this is a 1, they cancel each other out. So the cube root of 0.5, if you did that, what is the cube root of 0.5? F18. Clear. 0.5 to the power of parentheses 1/3. That's the cube root of 0.5. 0.79 times the negative 8 plus the 8. So the top is 1.65 over a positive number. A positive over a positive, that's a positive. And that means the function is increasing. That's the midpoint. The 5, the top will be negative. This will be more than 1, so this will be negative. The bottom is going to be what? Positive. What's the negative over positive? Negative. That's decreasing. That's the max. I'm done with the first derivative. Now let's do my second derivative. 8 times a negative 1/3, negative what? 8/3. X to what power? Negative 4/3, which is negative 8 over 3 times what? The cube root of x to the 4th. That's really what that is. When is the second derivative equal to 0? None. When is the second derivative undefined? When the bottom is 0, that means x is 0. When the bottom of that fraction is 0. Extend that line. We'll use a -1 for a test point and a +1. Think about this. You have a number. It doesn't matter. It's positive or negative. When you raise it to the 4th power, what's going to happen to it? Positive, right? What is the cube root of a positive number? Positive times 3, that's a positive. What's a negative over positive? This is always negative, regardless what number you use. Doesn't matter what I use. Concave down. Concave down. Always negative on the top, always positive on the bottom. The result, negative by positive, is always negative. I'm ready to graph it. I'll do it on this sheet, since it's not really that too fancy. Here's what I know. At 0, 0, we have a point here. At 1 and 4, there's a point here. At 0, 0 is actually a min. So it's going to be like this. At 1 and 4, somewhere we have a max. Let's see what's going on. Before this point, the function is decreasing concave which way? Downward, right? decreasing concave down. Well, where's it coming from? Way up there, infinity. Looks like this. Decreasing concave down. What happens once you hit this point and before you get to the 1? It's increasing concave which way? Downward. It's a V shape. See that? And what's the story after that? The function is what? Decrease concave downward. So you have a V shape right here. And we'll stop with this section. I got to finish the last one.